Hello everyone, I think we will get started. So welcome very much to this live webinar about how to manage intralogistic projects. My name is Per and I will be your presenter today. And today we are pretty few joining this webinar, so if you have some questions, it's okay to ask those during the webinar so we can have a discussion if you have any question. So today we will talk about intralogistic projects, and then the first question, of course, is what do we mean with intralogistic projects? So if we start with logistics, what is the logistic operations? So if you do some Googling, if you search the internet, you will find some different definitions, but they are all pretty much the same, and this is from Wikipedia, and it says that logistics is the management of the flow of things between the point of origin and the point of consumption in order to meet requirements of the customers. So it means that you have, in our case, we have parts, and in the project we are organizing activities, we are organizing equipment and so on in order to deliver this part to the customer. So that is the main meaning of intralogistic projects. And when we say intralogistic, that means that we are looking into logistics that are happening inside the plant or inside a warehouse, for example. But it's not a logistic between different plants. So it's not like the supply chain from supplier to the plant. We are looking inside the factories and the inside flows. So in this box here where we have the question mark, there are some different areas that we need to look into when we run our intralogistic projects. And those areas are things that needs to be considered. And of course we have stakeholders. We always have stakeholders for projects that have different needs and different requirements. So it's really important to look into those requirements and try to document and define that in the best possible way. We need movers. We need some way to move material, move parts inside the factory. We need carts. That's a very central, it's an important part of intralogistic projects. We have the supply plan. So for each part, we need to know when and how are we going to supply it. Of course, we have the layout. If we design a good layout, it will have a very big impact on the intralogistic operations, and we will save a lot of money and increase efficiency if we can manage to make a good layout. And then finally, we have material presentation, and that means how do we present the parts for our final customer? How can we present it in the best way in order to fulfill the end customer requirements? So this is the main cornerstones that you do in intralogistic projects. But projects isn't that easy. The project, normally you define it as activities where you have a limitation in time, you have a limitation in the scope, and you have a limitation in the budget. That is the definition of a project, that you have those limitations. But it seems to be pretty tricky to fulfill those targets. There is a lot of statistics available that most projects fail in doing this. So this is some interesting projects that over 1/3 of all projects they don't even have a baseline, and the baseline, that is the time, the budget, and the scope. And if you don't have that, it's impossible to know if you will succeed or not with your intralogistic project. And only 1/3 of the projects are successfully completed on time and on budget. So most projects are delayed or are using more money than was planned from the beginning. But still, almost all organizations believe that the project management is really critical to their business performance, and they see the projects as the most suitable way of transforming their operations. And then we have some other statistics, but overall projects are really tricky. And this change is contributing to that we have a really fast pace of change in our surroundings. The world is changing, the technology is changing, and also people are changing. And the only thing we know is that change is kind of the only constant. So this is something that we need to handle, and this change pace will be even faster in the future. And if we look into how this will affect intralogistic projects, I just wrote down some different examples here. So if we look at the world, we can see that we have many different markets for the products that we produce. We have high-end products, we have low-end products, low-cost countries, and so on. So it's a wide spectrum of customers that we need to make happy with our products. And in order to do that, we need to have a big variation of product. We also have different regulations. So for example, environmental regulations for powertrains, for example, you have tier 1, tier 4, and so on. So that is also something that adds a lot of complexity to production, because it means that we will have variants to handle those regulations. And I think based on history, we can also see that there are, when it comes to the demands, it's very fluctuating. So the demand can change rapidly, and it can change between different regions rapidly. Then we have a technology, and that will have a huge impact on our intralogistic projects. We have the so-called Industry 4.0. That means that we're using a lot of IT. We have connected machines, connected equipment. We store everything in the cloud, and we have like machines and equipment that can analyze its own performance. So this is something that we will see a lot of in the future. We also have increasing level of automation, and we see that the self-driving vehicles are also increasing pretty fast in order to make intralogistic more efficient. And we can also see that this type of automation also becomes more affordable, which means that we will not have or the level that you need to invest in order to increase automation has decreased lately, because it's getting more and more general technology into the equipment. And finally, we also have flexibility. We see that flexibility is more and more crucial in order to handle the change. So if you change the layout, if you change products, if you change volumes and so on, the technology always needs to be flexible to handle that, and it's something that we see as well. And then we have people. People are more and more working in global teams. So you have like teams working in different countries, different regions. It's like virtual teams. You don't meet, but still you need to create a really good results together. And we also have increased number of stakeholders. And I think especially logistic projects, those kind of projects involves a lot of stakeholders. So that is a really challenge to meet the requirements of all those, and to find the best, the best compromise so that everyone is happy. And also limited resources. We are expected to do more with less. So that will force us to work in a more efficient way. So when it comes to how the market change, this is a slide that we normally show in all webinars, but it's really the basic behind the FLEXQUBE concept and why it's needed. So we see that we have a lot of products and variants, and this is increasing all the time. We can see it within automotive, we can see it within commercial vehicles, we can see it within mobile phones and so on. We can see it in almost any market that we have increased the number of products and variants. And in the same way, the total volume isn't like increasing as fast as a number of variants. That means that the volume for each variant is decreasing. So we are having a lot more variants based on the same volume. And in addition to this, we also decrease the life cycle of each product. So maybe in the past, a car, for example, had a life cycle of 10 years, but now maybe the life cycle is only 3 years, and you have the facelifts and so on. So it's really required from the customer that you do the updates more and more frequent. And if you don't do it, you will not sell as much products as you want to do. And this trend leads to a really big challenge for logistics. And this is why logistic or intralogistic projects are really important, because it will have a huge impact on the cost and also the efficiency in our manufacturing plants. Because what we can see is that the footprint used for logistic operations are increasing. In the past, the material was stored close to the assembly line, for example, but now we see a trend that we have so many part numbers, so the parts are stored in a kitting area, and for that, of course, you need some space and an area to fulfill that, to have the ability to prepare and kit the materials. So we see this trend that you need more and more space in order to handle all the different parts. So the logistic operations is almost as big or even larger than the actual assembly or manufacturing activity. And before you start the project, it's really important to define your goals. As we see in the beginning here, 1/3 of the projects are missing the baselines. So this is something that needs to be defined before you start. Why are you doing this intralogistic project? And it could be a lot of different reasons. And if you prioritize one measurement, maybe you need to compromise on another, for example. So it's really important to have this picture clear before you start a project. But it could, for example, be that you want to increase the inventory turnover. Maybe you want to decrease the walking distance for the assemblers to prepare the material in a better way, for example. You want to reduce the number of forklifts, reduce the travel distance. Also, area is a big focus area in many plants, to try to produce more products with on a less area. So it's like products per square meter. Then we have the number of operators. That is also, of course, something that enables that you can make things more efficient if you can do more with less people. You can measure the number of accidents. You can look into the ergonomics, how many parts are presented in the green zone or in the ergonomic zone today, and what is the target for the future. Number of handlings is also something that we see a big focus on. For example, you receive the part from a supplier. How many times do you need to handle the material before it ends up at the end customer? Of course, the best thing is if you don't need to have a lot of handles, but on the other hand, it can enable that the parts are presented in the most efficient way for the end customer. But in general, we see more and more combined process steps, so you can reduce the number of handlings. Maybe you want to increase the line side flexibility. That means that you want the flexibility that enables you to present a lot of different parts on the assembly line. Because if you can do that, that means that you can produce a lot of different variants or different products on the assembly line. And that creates a flexibility to actually produce what the customer is asking for. And in that case, the logistic is an enabler to handle many different variants on the same production flow. And then we have energy consumption, and we have target that could be to reduce non-conformity parts. That could be to change the packaging, for example, to change the quantity, and to transport and treat the parts in a different way that makes sure that they don't have any non-conformity or damages when it arrives to the final customer. One pretty famous project, or something that we see a lot of companies are doing, is the forklift-free activities. So this is a lot of our of the FLEXQUBE projects that are running is related to this in some or another way. That companies want to reduce the number of forklifts because it will have or it has such a big impact on safety and also efficiency. This is some statistics regarding safety. We can see that only in the US we have 85 fatal accidents every year, and we have almost 35,000 injuries, and these are related to operators that are being crushed by the tipping vehicle, but it's also related to that pedestrians and so on are hit by the forklifts. So it's in overall it's a pretty dangerous machine. Going forklift doesn't mean that you reduce the forklifts totally. It means that you choose where to use forklift and you choose where to be forklift free. This is one example which impact it will have on efficiency. So we have a forklift to the right and a tugger train to the left. And we are going to replenish 5 Euro pallets to a kitting area. And with the forklift, you take the full pallet, you transport it to the point of consumption, and then you take the empty pallet with you back, because you can only handle 1 pallet at a time. So you can see that you need to make a lot of routes. With a tugger train solution, you have 1 continuous loop. You can pick up the empty pallet and you can supply a new pallet, because the pallet are always placed on a cart. That means that you have a quick transition. You can replace the pallet in a fast way, and you don't need to go back to the warehouse after each replenishment. So this is one very simple example of business case, but I think in most cases when it comes to logistics, the business case, it's not a very complicated calculation. It's more to really understand the flows and put figures on each step. As we saw in the beginning, the input to our intralogistic projects are always the parts. I mean, that is why we are doing the projects. We want to move the parts, we want to present the parts in the very best way for our end customers. That could be an assembler, it can be a welder, it can be someone working in a warehouse. But our task is to make sure that the part end up in a good condition, in a good ergonomic height, and so on. And this is an example from a car. The car is approximately containing of 30,000 parts. If you look into the bolt and nut level, it's 30,000 parts. And of course, those comes from different suppliers, different countries. Maybe some of them are produced in-house, for example. And of course, those parts, we need to look into this in a structured and organized way. So to do that, there are some different categories to use in order to place the different parts in in different groups, to make some rough categorization of the parts by looking at those parameters. So this is just examples, and for each plant I'm sure it could be other aspects as well, but this is like a first guideline. So the first thing to evaluate is the value of the part. Is it a very cheap part, or is it really, really expensive? What is the size of it? Is it a small bolt, or is it a big body in white for a car? What is the weight? That will affect very much how you transport the part. How is the shape? Is it a very simple shape, or is it a long part? Is it a complex geometry, and so on? Also, the volume have a very big impact how we will plan and how we will transport the part. If it has a very low volume, maybe it's not used on all the products, then maybe you should do some kitting. But if it's very high volume, maybe you should present the part at a line side. So it's those kind of discussions that will come up when you look into those different parameters. And also the distance to the supplier. if you have a nearby supplier, or if you have a global supplier that are weeks away with the boat transport. That will also affect how you treat that part in your flow. So if we take a bolt, for example, it's a very low volume, small size, very light, pretty normal part, and normally also very high volume on this. If we take an engine, for example, that has a very high volume, medium size, but we have a heavy weight. Volume wise, probably pretty high volume, but not as high as the bolts. And in most cases, maybe you buy the engine from some global supplier, or you can buy it nearby. This is just examples of how you can categorize the different parts. This shows a sheet metal. This is hydraulic hose that we have categorized in the same way. But the idea with this is to go through and have a plan for each part so you understand the basic needs. Because if you know those parameters, it's easier to take the next step. And the next step is to look into first, how are we going to replenish this part? And the second question is, how are we going to present it? How will the material presentation be? So when it comes to replenishment method, there are some different options. So we have the sequence. Sequence delivery means that we know the date and we know the time. For example, this engine is needed tomorrow 3 o'clock on the assembly line, and then we will bring it there at that time to a specific position. That is a sequence delivery. We deliver it to a specific sequence on the line. When it comes to Kanban, that means that we have Kanban cards. So each card represents emballage or a box or whatever. It represents. It's a visual way to show the deliverers. So if you have like different cards, and then you send the card to the warehouse, that is a signal for the warehouse to prepare new parts. And you can never have more emballage in the loop than you have Kanban cards. Then we have a 2-bin system. That means that, for example, if you have an assembly line, you have 2 bins of the same part. So you have part A and part A, you have it presented twice. And when one is empty, that is a trigger to replenish a new one. So you will always make sure that you have at least one full pallet on the point of consumption. Then we have the VMI. That is when the vendor is doing the supply. That means that they could, for example, have web cameras, or they can have other system to have a signal when they need to replenish material. And you can also have a manual trigger. So, for example, if an operator see that this pallet it seems to be running out of parts, so maybe they do a manual order for new parts when they see that the level is very low. And I placed the parts from previous slides here. So, for example, you could choose to have a kit for the hydraulic hoses. That is pretty common, because that is normally that you have a lot of different variants, and you want to have the hoses in a kit that are used for one specific product or one specific machine. And by doing that, we know that it can be delivered in sequence. So those hoses will be, it's needed for a specific product at a specific time. The engine, for example, it's the same thing. That is a high value part, so we don't want to store a lot of engines at the line side. We deliver the engine when it's needed. So we will use a custom rack for that, and we will deliver it in sequence. If we take the bolt, for example, that is a very high volume part. So one option is to store the bolt in totes, and we have the VMI, so we have a supplier nearby that will see the levels of the totes, a level inside the totes, and they are responsible for replenish. the bolts. But this is just examples, but it's one way to categorize the parts in your intralogistic projects. And then we have the stakeholders. In intralogistic projects, you have some internal stakeholders, so it can be assembler, production engineer. You have the warehouse operators, the one that will handle the carts, drive the trains, and so on. You have the plant manager. You have purchaser that are responsible for doing all the investments and ask for bids and quotes. Logistic engineer and maintenance engineer. And of course, those have all different interests and they have different requirements based on their daily work. So this is some examples of their interest. And as a project manager or managing the project, it's really important to bring all the needs together. It's something that we see sometimes that all people are not involved in the projects, or they are not involved at the same time, and then it can be some surprises during the project. So try to have a tight team, and everyone is really needed in order to come up with a good result. This is some different mover options that should be considered in the project, and you can choose different based on how long distance you're going to move, how frequent you're going to do the move, and also the weight and the size of the parts that you're going to move. So if we have a short distance movement, the Juman and the push unit, or the power caster is some options. If you have more long distance transportations, a tow tractor is, I would say, the most common, but we see increasing use also for the self-driving vehicles. We also have mother-daughter solutions, and of course companies are still using forklifts, but it's more and more taken away for transporting material. If you have a successful forklift-free project, the forklifts are only used to lift the material. It's never used to transport the material. But anyway, this is the transport options that needs to be considered in an intralogistic project. This is some picture examples where you move carts with a tugger. So this is pallet carts and shelf carts, and you can run those in pretty long trains in order to have efficient transportation. This is another move option where you use a mother and daughter solution. So the orange frame is the mother and the blue cart is the daughter. And by having this solution, you can replenish the carts independent of each other. This is also some example of tugger trains. This is showing FLEXQUBE cards together with AGVs. And here you also have some different integration options. But as I said, this is also a growing area as AGVs are getting more and more flexible. They require less infrastructure in the plants, and they are also becoming more affordable. So this is something that you will see more of in the future. When it comes to the layout, it's a lot of things to consider. You need to consider the supply routes, the aisles, the width, for example. The trend is to make more and more narrow aisles to save space, and that will have a huge impact on the choice of carts, for example, and the transport method. We have driver visibility. We have travel directions. We see that one-way routes is one way to save space, for example, but that will require that you have a good planning of your logistic process, because in that case you are always replenished to one side of the line, and you really need to have a good plan so you know that you can supply the correct parts in the correct position and right time and so on. Then you have some other parameters: floor quality, receiving area, picking areas. When it comes to picking areas, we see that those are more and more located close to the point of consumption. So if you have an assembly line, the picking areas are located very close in order to have a smooth material flow. Then we have, you should consider if you have outside routes, pedestrian areas, and forklift areas. And that is one of the key targets with forklift free projects, to define which area to use the forklift and how to use it. And also drop-off zones, where in the plant are we drop off the material for the final customer. Then we have the carts, and the carts are really they connect a lot of different stakeholders. You can, most people probably think that cart is a pretty simple stuff, but it actually becomes pretty complex from a stakeholder perspective, because there are so many stakeholders that have some kind of connection to the cart. Because if you see here, it shows the design process for the carts, but it also shows how it connects to the different areas. So it's really dependent of the layout. If you make a good cart solution, you can fulfill your layout requirements. You need to connect to the movers. You need to have interface to a tugger train or interface to an AGV. And you also have an interface to the load. So if you're going to transport a pallet or a kit or whatever, that will also end up on the cart designer's table. And all the requirements from the operators, ergonomics and so on will also end up on the cart designer's table. So it's a lot of considerations to do here. And as you can see, most to the left, the FLEXQUBE carts are built with modular building blocks. So it's the flex beam, FLEXQUBE, and flex plate. So it's 4 different building blocks. So you can see this as Lego bricks with standardized interface that you know that they will fit together. And by combining this, you can build a lot of different carts. You can make rotating carts, shelf carts, padded carts, and so on. Tilt carts, flow racks, kit carts, transport racks. So this shows some example. It's more or less the imagination that is the limit here. This shows different ways of doing projects, but if we look at the traditional way, for example, if you are using equipment that are not flexible or that are not easy to change, the normal way to do projects is that you work a pretty long time on the idea, you do a lot of investigation, you try to come up with a perfect solution from the start, and then you do the investment, and then you are implementing, and you have spent so much time on investigating different ideas that you have a very limited time for implementation. What we propose with a modular concept like the FLEXQUBE is that you can take it in small steps. So if you have an idea, you can build a prototype, you can adjust, you can try different things, and then you do it in loops. So you always take small steps instead of try to solve all the problems in one step. And this will also involve a lot of different people. So it will involve the operators, the assemblers, the warehouse guys, and so on. So it will force the team to work together. And if you want to create the FLEXQUBE cart, there is 2 different ways of doing it. You can do it on your own. That we call Design for All, and we give support in order to do that. Then we have Design on Demand, and in that case we are doing design for you. And both options are a fast and flexible way to create the cards. This shows the Design on Demand process. And this is totally unique, and it's a really efficient way to gather your cart requirements into a final solution. So the core in this is to have a meeting, and that is a live meeting. You have it on the web. So you can gather your team, different stakeholders, to join this meeting. And before the meeting, you do some different preparations. It can be you look into the loads, you can look into the routes, you can look into the number of carts that you need and so on. But you do some preparation before the meeting, and then our designer have a better chance to come up with the best design. And then during the meeting, you do some brainstorming together to come up with a concept and a draft of a cart. And after the meeting, we will have a CAD model that you can review, and we will have some rough pictures and sketches and so on. And based on that, when we agree on how the design should look like, we finalize the design. So the meeting is 1 hour, and then we have a goal to finalize the design within 1 week. So after 1 week, you will have a fully offer from us. That shows different, it will have documentation, such as drawings, renderings, it will have the quote, of course, and a bill of materials. So you will have a really good documentation of the cars that we have created. And this shows the loop. So if you want to have a flexible project, or you want to do it in small steps, so this is how you can do it. When you have evaluated the prototype, you can discuss internally, and then we can start the loop all over again, and we have a new meeting to do the updates for you. So this is a continuous process during a project to fine-tune the solution and really find the final way to go. This shows design for all process, and in this case, as it says, you do the design on your own, but you can have training from our designers, and you can also have meetings in between here to have support how to review design, so they can give input if the design is good and how you can change it in order to make it even better. And based on that, we will have a bill of material, and we can prepare an offer, just as we do in design on demand session. This is the different softwares, and we can now provide downloads for Solid Edge, SolidWorks, CATIA, and Inventor. And we also have the files in STEP. So if you don't have any of those softwares, you can download in STEP and then transform into your native CAD format. And we are also working in Onshape. And in that case, you don't need to download anything. It's in the cloud. And this is pretty unique, but it's really aligned with the FLEXQUBE ID to keep everything available. It's a flexible way, so the only thing that you need is a web browser. And in this web browser, you can find the FLEXQUBE building blocks. And by using those building blocks, you can create different cards, you can create bill of materials just directly in your web browser. And we had a webinar about this a couple of weeks ago, and there is a lot more information available on this if this is of interest. Yeah, to summarize a little bit about the FLEXQUBE concept. We have our modular building blocks, and it's independent of the platform that you choose in your project. So you can choose mother-daughter solution, you can choose AGV, you can choose a tugger. It's still applicable to combine with our modular building blocks, and we will create a custom solution for it. You can design on your own, or you can design with the help of FLEXQUBE, which we call design on demand. We also have global distribution, That means that we have the same building blocks available globally, and we have distribution centers in both Europe and the US in order to deliver parts as soon as possible. We have a wide customer base, which means that we are working together with a lot of different customers within different segments, like automotive, commercial vehicles, aviation. We also work in the food industry, and yeah, it's a wide range of customer, which gives us a lot of inspiration how to design different cards. We have the appearance. We believe, or we think, that our concept looks pretty good. It's a pretty futuristic design, and there's also options to have different colors and so on. It's a really good replacement for welded cards. It's a much quicker design process. It's a lower weight of the card, and it's easier to build, and it's easier to change if something needs to be changed. Flexible delivery options. We have talked about this before, but it's standardized building blocks. It's easy to repair, so if one card is damaged, you don't need to replace the complete card. You can just replace one of the building blocks. We work a lot with documentation, so every time we provide or every time we design a card, we do product documentation, we make drawings, we make nice photo-like renderings, you have 3D PDFs and so on. So you have a really good material into your project to make presentations and internal material in order to take the best possible decisions. Yeah, and I want to promote our solutions library, which is inspiration for all the project members. It's a library where you can find a lot of different solutions. Palette cards, kit cards. You have a search function, so you can find almost any card for different needs. So this was everything for this webinar. Next time we will look into more specific the AGV business, different type of AGVs, and how the AGVs are integrated with the flexible cards from FLEXQUBE. So that is the 10th of November. So that's it. I will stay here for some more minutes if you have some questions. Otherwise, we will end this webinar.